Okay guys, in this video I want to talk a little bit about a special type of trapezoid, and so I've drawn this situation here. We know, of course, think back to the last video, a trapezoid is a quadrilateral with only two lines that are parallel. So one set of parallel lines, and then we learned that those are called the bases, and then you have these are called the legs. And so we have a special type of trapezoid. It's called an isosceles trapezoid. And you can think about what that probably means. Just like an isosceles triangle, this is a trapezoid with congruent legs. Okay, a trapezoid with congruent legs. So if these two legs are congruent, we say it is an isosceles trapezoid. So that's the definition. There are a few different properties here, or theorems, all right? If a trapezoid is isosceles, the base angles, just like in a triangle, are congruent. And so why is that? Okay, well, we have this situation here. Okay, we have a trapezoid, all right? Now, we know how to draw a line parallel. Oops, that's not a very good line, but let me redraw it here. Okay, so we know how to draw a line parallel, all right, with this line. Let me put some letters in here, A, B, C, D. Now, since I've drawn a parallel line here, we know that if these parallel lines are cut by a transversal, okay, so we know that these angles are going to be the same. All right. We also know that these angles are going to be the same. Okay. We know that since this line is parallel to this line, we know that this is an isosceles triangle. Okay, so this is going to be isosceles. So we know that these angles are going to be the same. Okay, so this is going to be, let's see here. This is also going to be here. Okay, this triangle will be isosceles. Huh? And so we have this setup here. So going back to the original, we're trying to prove that the base angles are congruent. Now we know that we can see angle A is congruent to angle D. Okay, so that's two of the base angles. Now the other base angles, we know that angle A plus angle B must equal 180. We also know that angle C plus angle D must equal 180. Okay, so we know that these things then equal each other. So let me move over here. Angle A plus angle B equals angle C plus angle D. Okay, but we know we can substitute in here. We can substitute A for D. So angle D plus angle B equals angle C plus angle D. So now we have an angle D on both sides. Angle B equals angle C. So that is the other part of the other two base angles. So if a trapezoid is isosceles, the base angles are congruent. Let's look at this next theorem. If a trapezoid has one pair of congruent base angles, then it is isosceles. So if a trapezoid, so again, the definition of a trapezoid is a quadrilateral with only two sides that are parallel, has one pair of congruent base angles, so that's here, then it is isosceles. So we're trying to prove that these two sides equal each other. Okay, so what we can do here, so let's label this A, B, C, and D. Okay, so what we have to do here is I want to draw a point here and make a right triangle. Okay, so I want to make a right triangle here, and I want to make a right triangle here. Now we know that since these two lines are parallel, we know that this line and this line are going to be the same. So we know that this and this are congruent. And so we also know that if in this situation here, because this is a parallelogram, we know that this is also a right angle. Okay. So given that, we know that this angle is congruent to this angle. Okay. So if we know that's true, then by LA, leg and angle, right triangle congruence, we know that this triangle and this triangle are congruent. Okay, so we know that these two green triangles are congruent by LA theorem. Okay, and if they're congruent, then we know that the hypotenuses are congruent. Therefore, let me write this down. AB is congruent to CD. Okay, and if these are congruent, then the definition of isosceles is true. Third theorem: a trapezoid is isosceles if and only if its diagonals are congruent. So if and only if, again, that's written IFF. If and only if. That means that you have to work both ways. So what that means is a trapezoid is isosceles if its diagonals are congruent, and if a trapezoid's diagonals are congruent, then it's isosceles. So let's work on the first part of this statement. A trapezoid is isosceles if its diagonals are congruent. So we have a trapezoid here. I'm going to draw in the diagonals. Okay. And what we have here is it says that these we can show that these two triangles are congruent. So here's why. A trapezoid is isosceles if its diagonals are congruent. So we know it's isosceles. Okay. We know from theorem 2, from theorem 1, if a trapezoid is isosceles, the base angles are congruent. So we know that these angles are congruent. And let me put some letters in here. A, B, C, D, and E. So we have SAS and SAS. So we know that triangle ABD is congruent to triangle, let's see, ABD, CDA, and this is by SAS, so by SAS. Therefore, the diagonals are congruent. AC, let me write that a little bit better. AC is congruent to BD. Okay. Now the other side of the coin says a trapezoid is if you have a trapezoid with congruent diagonals, then it is isosceles. So we have to kind of set up a different picture, but basically you're going to use the same logic. So let me just draw this quickly. Okay, so the opposite of this, or the converse, would be if the diagonals of a trapezoid are congruent, then it's isosceles. So let me draw that. We have a trapezoid here, okay, and if the diagonals are congruent, okay, if the diagonals are congruent, in other words, A, B, C, D, okay, so we have, let's see here, AC is congruent to BD. So here's what we know, that this line and these lines are the same. Okay, now I want to draw a some right triangles here. Okay. Now, since we know, I want to look at this triangle, B, and we'll call this point E and F. Okay, so we know since these lines are parallel, we know that this distance is the same. Okay. Now we have two right triangles. So we have triangle, let me write this over here, triangle FAE. Sorry, FAC. So FA to here, this white point C. So FAC is congruent to EDB, triangle EDB, by, let's see, this is by, well, we have HL. So by HL, right triangle congruence. So we know if those, let me make this a little better. So if that is true, then we know that this angle equals this angle. So angle DBC equals angle ACB. Okay, that's by definition of congruence. So if that is true, then we know we have side, angle, side. So side, angle, side. So by SAS, ABC, triangle ABC, triangle ABC is congruent to triangle DCB, which shows that AB and CD are congruent. So we know that these are congruent, which is our definition of an isosceles trapezoid. Let me review just briefly again why. So we know that by SAS, triangle ABC, so again, ABC, this triangle, is congruent, sorry, this should be congruent to triangle DCB. And this should also be congruent here, so I made a little mistake there. But basically, that's how we solve that. In our next video, we're going to look at some examples involving isosceles trapezoids. Thanks for watching.